According to the National Electrical Code, specifically Article 500, a classified location is an area where hazardous concentrations of flammable gases or vapors may exist. To determine if the described oil room qualifies as a classified location, several factors must be considered. Firstly, the National Electrical Code defines a volatile flammable liquid based on its flash point. If the liquids present in the room do not meet the code's definition of a volatile flammable liquid, this is a significant factor against classifying the area as hazardous. Secondly, the absence of gas buildup is crucial. Classified locations typically involve environments where flammable gases or vapors accumulate, posing a risk of explosion or fire. If there is no buildup of gases in the oil room, this further supports the conclusion that it is not a classified location. Thirdly, the physical characteristics of the area also play a role. While the described oil room is within a larger room and merely fenced off, the key consideration remains the presence of hazardous materials. The absence of both volatile flammable liquids and gas buildup suggests that the area does not pose a significant risk. Therefore, based on the information provided, the oil room does not meet the criteria for a classified location as defined by National Electrical Code Article 500. It's important to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and standards. The National Electrical Code provides detailed guidelines for identifying and classifying hazardous locations, and a thorough understanding of these guidelines is essential for ensuring electrical safety. The following are some examples and explanations of hazardous locations and their classifications according to the National Electrical Code, or NEC. Hazardous locations are classified based on the type of hazard present, the likelihood of the hazard being present, and the properties of the hazardous material. The NEC classifies hazardous locations into three classes: Class 1, Class 2, and Class 3, and two divisions, Division 1 and Division 2. Each class represents a different type of hazardous material, while each division represents the likelihood of the hazardous material being present. Class 1 locations are those in which flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 1 locations are further divided into two divisions, Division 1 and Division 2. A Class 1, Division 1 location is one in which ignitable concentrations of flammable gases or vapors exist under normal operating conditions, or where such concentrations may exist frequently because of repair or maintenance operations, or because of leakage, or where breakdown or faulty operation of equipment or processes might release ignitable concentrations of flammable gases or vapors and might also cause simultaneous failure of electrical equipment. Examples of Class 1, Division 1 locations include petroleum refineries, gasoline storage and dispensing areas, and spray finishing areas where volatile flammable solvents are used. A Class 1, Division 2 location is one in which volatile flammable liquids or flammable gases are handled, processed, or used, but in which the liquids, gases, or vapors are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment, or where ignitable concentrations of gases or vapors are normally prevented by positive mechanical ventilation and which might become hazardous through failure or abnormal operation of the ventilating equipment, or where the area is adjacent to a Class 1, Division 1 location, and occasionally the hazard might be communicated. Examples of Class 1, Division 2 locations include storage areas for flammable liquids in closed containers, areas where flammable gases are used for welding or cutting, and areas adjacent to Class 1, Division 1 locations. Class 2 locations are those in which combustible dust is or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 2 locations are also divided into two divisions, Division 1 and Division 2. A Class 2, Division 1 location is one in which combustible dust is in the air under normal operating conditions and quantities sufficient to produce explosive or ignitable mixtures, or where mechanical failure or abnormal operation of machinery or equipment might cause such explosive or ignitable mixtures to be produced, and might also provide a source of ignition through simultaneous failure of electrical equipment, operation of protection devices, or from other causes, or in which dust of an electrically conductive nature may be present. Examples of Class 2, Division 1 locations include grain elevators, flour mills, coal preparation plants, and areas where metal dusts are produced or handled. A Class 2 Division 2 location is one in which combustible dust is not normally in the air in quantities sufficient to produce explosive or ignitable mixtures, and dust accumulations are normally insufficient to interfere with the normal operation of electrical equipment or other apparatus, but combustible dust may be in suspension in the air as a result of infrequent malfunctioning of handling or processing equipment, or where dust accumulations on electrical equipment or other apparatus may be ignited by abnormal operation or failure of electrical equipment or other apparatus. Examples of Class 2 Division 2 locations include storage areas for bagged or packaged combustible dusts and areas where dust accumulations may occur due to infrequent spills or leaks. Class 3 locations are those in which easily ignitable fibers or materials producing combustible flyings are handled, manufactured, or used, but in which such fibers or flyings are not likely to be in suspension in the air in quantities sufficient to produce ignitable mixtures. Class 3 locations are not divided into divisions. Examples of Class 3 locations include textile mills, woodworking plants, and areas where paper or cardboard is processed or converted. In addition to the class and division, hazardous locations are also grouped based on the ignition temperature of the hazardous material and the design characteristics of the electrical equipment. These groups are designated by the letters A, B, C, D, E, F, and G. Each group represents a different type of hazardous material, with Group A being the most hazardous and Group G being the least hazardous. Group A includes acetylene. Group B includes hydrogen, manufactured gas containing more than 30% hydrogen by volume, or gases or vapors of equivalent hazard such as butadiene, ethylene oxide, propylene oxide, and acetylene. Group C includes ethyl ether, ethylene, or gases or vapors of equivalent hazard. Group D includes acetone, alcohol, ammonia, benzene, benzol, butane, gasoline, hexane, lacquer solvent vapors, naphtha, natural gas, propane, or gases or vapors of equivalent hazard. Group E includes metal dusts, including aluminum, magnesium, and their alloys. Group F includes carbon black, coal dust, coke dust. Group G includes flour, starch, or grain dusts. Electrical equipment used in hazardous locations must be designed and tested to prevent ignition of the hazardous material. This is typically achieved by using explosion-proof enclosures, intrinsically safe circuits, or other methods that limit the energy available for ignition. Explosion-proof enclosures are designed to contain an internal explosion without allowing the explosion to propagate outside the enclosure. Intrinsically safe circuits are designed to limit the energy available in the circuit to a level that is too low to ignite the hazardous material. Other methods of protection include purging, pressurization, and encapsulation. Purging involves continuously flushing the enclosure with clean air or inert gas to remove any hazardous material. Pressurization involves maintaining a positive pressure inside the enclosure to prevent hazardous material from entering. Encapsulation involves sealing the electrical components in a resin or other material that prevents contact with the hazardous material. It is important to note that the requirements for electrical equipment used in hazardous locations are very strict, and that only equipment that has been specifically designed and tested for use in hazardous locations should be used. The National Electrical Code provides detailed guidelines for the selection, installation, and maintenance of electrical equipment in hazardous locations. Proper classification of hazardous locations and selection of appropriate electrical equipment are essential for ensuring the safety of personnel and property. It is recommended to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards. Here are some additional considerations and clarifications regarding hazardous locations, expanding upon the information already provided. Firstly, the determination of whether a location is hazardous requires a thorough assessment of the specific conditions and materials present. This assessment should be conducted by qualified personnel who are familiar with the requirements of the National Electrical Code and other applicable standards. Secondly, the classifications of hazardous locations are not always clear-cut, and there may be situations where a location could be classified as either Division 1 or Division 2, depending on the specific circumstances. In such cases, it is important to err on the side of caution and classify the location as Division 1. Thirdly, the requirements for electrical equipment used in hazardous locations vary depending on the class, division, and group of the location. It is important to select equipment that is specifically designed and tested for use in the particular hazardous location where it will be installed. Fourthly, the installation of electrical equipment in hazardous locations must be performed by qualified personnel who are familiar with the specific requirements for hazardous locations. The installation must be done in accordance with the National Electrical Code and other applicable standards. Fifthly, regular inspections and maintenance of electrical equipment in hazardous locations are essential to ensure that the equipment continues to function properly and does not pose a hazard. The inspections and maintenance should be performed by qualified personnel who are familiar with the specific requirements for hazardous locations. Sixthly, it is important to keep accurate records of all hazardous location classifications, equipment installations, inspections, and maintenance. These records can be used to demonstrate compliance with applicable codes and standards and to help identify potential hazards. Seventhly, the National Electrical Code is not the only standard that may be applicable to hazardous locations. Other standards, such as those issued by the Occupational Safety and Health Administration, or OSHA, and the National Fire Protection Association, or NFPA, may also apply. It is important to be familiar with all applicable standards and to comply with the more stringent requirements. Eighthly, the classification of hazardous locations can change over time as conditions change. It is important to periodically reassess hazardous locations to ensure that the classifications are still accurate and that the electrical equipment is still appropriate for the location. Ninthly, the use of intrinsically safe circuits can be a cost-effective way to protect against ignition in hazardous locations. Intrinsically safe circuits are designed to limit the energy available in the circuit to a level that is too low to ignite the hazardous material. Tenthly, the use of explosion-proof enclosures can be an effective way to contain an internal explosion without allowing the explosion to propagate outside the enclosure. Explosion-proof enclosures are designed to withstand the pressure of an internal explosion and to prevent flames or hot gases from escaping. The intent of these classifications and requirements is to minimize the risk of fire or explosion in areas where flammable materials are present. Adherence to these standards is critical for ensuring the safety of personnel and property. For example, consider a chemical plant where various flammable liquids and gases are processed. The plant would be divided into different zones, each classified according to the likelihood of flammable materials being present. Areas where leaks or spills are likely to occur under normal conditions would be classified as Class 1, Division 1. Areas where flammable materials are normally contained but could escape under abnormal conditions would be classified as Class 1, Division 2. Electrical equipment used in these areas would need to be specifically designed and certified for use in the appropriate class, division, and group. This might include explosion-proof motors, sealed lighting fixtures, and intrinsically safe control circuits. Regular inspections and maintenance would be essential to ensure that all equipment is functioning correctly and that there are no potential ignition sources. Similarly, a grain elevator, where large quantities of combustible dust are handled, would be classified as a Class 2 location. Areas where dust is normally present in the air would be classified as Division 1, while areas where dust is only present under abnormal conditions would be classified as Division 2. Electrical equipment used in these areas would need to be dust ignition proof, meaning that it is designed to prevent dust from entering the enclosure and causing an ignition. In a textile mill, where easily ignitable fibers are present, the entire facility might be classified as a Class 3 location. Electrical equipment used in these areas would need to be designed to minimize the risk of ignition, such as by using enclosed motors and preventing the accumulation of fibers on hot surfaces. The specific requirements for each type of hazardous location are detailed in the National Electrical Code, and it is essential to consult the code when designing, installing, and maintaining electrical equipment in these areas. Failure to comply with these requirements can result in serious consequences, including fires, explosions, injuries, and fatalities. In addition to the technical requirements, It is also important to have a strong safety culture in any facility where hazardous materials are present. This includes providing training to employees on the hazards of the materials they are working with, implementing safe work practices, and regularly reviewing and updating safety procedures. It is also important to have an emergency response plan in place in case of a fire, explosion, or other incident. The plan should include procedures for evacuating the facility, contacting emergency services, and controlling the release of hazardous materials. By following these guidelines, it is possible to minimize the risk of accidents in hazardous locations and to ensure the safety of personnel and property. The National Electrical Code, specifically Articles 500 through 516, provides detailed information on the classification and requirements for electrical equipment in hazardous locations. These articles cover a wide range of topics, including the different classes, divisions, and groups of hazardous locations, the types of protection methods that are permitted, and the specific requirements for various types of electrical equipment. It is essential to consult these articles when designing, installing, and maintaining electrical equipment in hazardous locations to ensure compliance with the code. The National Electrical Manufacturers Association, or NEMA, also publishes standards for electrical equipment used in hazardous locations. These standards provide detailed specifications for the design, construction, and testing of equipment to ensure that it is safe for use in hazardous environments. It is important to select equipment that meets the applicable NEMA standards when working in hazardous locations. The Occupational Safety and Health Administration, or OSHA, also has regulations regarding hazardous locations. These regulations cover a wide range of topics, including the classification of hazardous locations, the selection and installation of electrical equipment, and the training of employees who work in hazardous locations. It is essential to comply with all applicable OSHA regulations when working in hazardous locations. In addition to these codes and standards, there are also various industry best practices that should be followed when working in hazardous locations. These best practices include conducting regular safety audits, implementing a lockout/tagout program, and providing employees with appropriate personal protective equipment, or PPE. By following these best practices, it is possible to further minimize the risk of accidents in hazardous locations. Here are some specific examples of how the National Electrical Code applies to different types of hazardous locations. Firstly, in a gasoline dispensing facility, the area around the pumps would be classified as a Class 1, Division 1 location because flammable vapors are likely to be present during normal operation. Electrical equipment in this area would need to be explosion-proof and specifically designed for use in gasoline dispensing facilities. Secondly, in a paint spray booth, the area inside the booth would be classified as a Class 1, Division 1 location because flammable vapors are present during the spraying process. Electrical equipment in this area would need to be explosion-proof and specifically designed for use in paint spray booths. Thirdly, in a grain elevator, the areas where grain is handled and stored would be classified as a Class 2, Division 1 location because combustible dust is likely to be present. Electrical equipment in these areas would need to be dust ignition proof and specifically designed for use in grain elevators. Fourthly, in a coal mine, the areas where coal is extracted and processed would be classified as a Class 1, Division 1 location because flammable gases may be present, and as a Class 2, Division 1 location because combustible dust is present. Electrical equipment in these areas would need to be explosion-proof and dust ignition-proof and specifically designed for use in coal mines. Fifthly, in a chemical plant, the classification of hazardous locations would vary depending on the specific chemicals being handled and the processes being used. Some areas might be classified as Class 1, Division 1, while others might be classified as Class 1, Division 2, Class 2, Division 1, or Class 2, Division 2. Electrical equipment in each area would need to be specifically designed and certified for use in the appropriate class, division, and group. In each of these examples, it is essential to consult the National Electrical Code and other applicable standards to determine the correct classification of the hazardous location and to select the appropriate electrical equipment. It is also important to have a qualified electrical engineer or inspector review the installation to ensure that it complies with all applicable codes and standards. Let's consider some common misconceptions about hazardous locations and how to avoid them. One misconception is that if a location is not specifically listed in the National Electrical Code as a hazardous location, then it is not hazardous. The National Electrical Code provides guidelines for classifying hazardous locations, but it is not an exhaustive list. It is the responsibility of the owner or operator of a facility to determine whether a location is hazardous based on the specific materials and processes present. Another misconception is that if a location is classified as Division 2, then it is not as dangerous as a location classified as Division 1. Division 2 locations are still hazardous, and the same precautions should be taken to prevent ignition. The difference between Division 1 and Division 2 is the likelihood of the hazardous material being present, not the severity of the hazard. Another misconception is that if electrical equipment is labeled as explosion-proof or dust ignition-proof, then it can be used in any hazardous location. Electrical equipment must be specifically designed and certified for use in a particular class, division, and group of hazardous location where it will be installed. A general-purpose explosion-proof enclosure is not necessarily suitable for all hazardous locations. Another misconception is that it is acceptable to modify or repair electrical equipment that is used in hazardous locations. Electrical equipment that has been modified or repaired may no longer be safe for use in hazardous locations, and it should be replaced with equipment that is specifically designed and certified for the application. To avoid these misconceptions, it is essential to have a thorough understanding of the National Electrical Code and other applicable standards. It is also important to consult with a qualified electrical engineer or inspector when designing, installing, and maintaining electrical equipment in hazardous locations. In addition to the technical requirements, it is also important to have a strong safety culture in any facility where hazardous materials are present. This includes providing training to employees on the hazards of the materials they are working with, implementing safe work practices, and regularly reviewing and updating safety procedures. The National Electrical Code, or NEC, is updated every 3 years, so it is essential to stay current with the latest requirements. Changes to the code can affect the classification of hazardous locations and the types of electrical equipment that are permitted. It is also important to be aware of any local amendments to the NEC that may be in effect. Local amendments can add or modify the requirements of the NEC to address specific local conditions. To stay current with the latest requirements, it is recommended to attend training courses, read industry publications, and consult with qualified electrical engineers and inspectors. It is also helpful to participate in industry organizations and attend conferences to network with other professionals and share information. By staying informed and following best practices, it is possible to minimize the risk of accidents in hazardous locations and to ensure the safety of personnel and property. Also, documentation is key. Always maintain detailed records of the classification of hazardous locations, the selection and installation of electrical equipment, and the training of employees. These records can be used to demonstrate compliance with applicable codes and standards and to help identify potential hazards. It is also important to have a system in place for managing changes to hazardous locations. Anytime a change is made to a process or material that could affect the classification of a hazardous location, a new assessment should be conducted to ensure that the classification is still accurate and that the electrical equipment is still appropriate for the location. In addition to the specific requirements for electrical equipment, there are also general safety precautions that should be followed in hazardous locations. These precautions include prohibiting smoking, open flames, and other sources of ignition, controlling static electricity, and providing adequate ventilation. It is also important to have a plan in place for responding to emergencies, such as fires, explosions, or releases of hazardous materials. The plan should include procedures for evacuating the area, contacting emergency services, and providing first aid. By following these safety precautions and having a well-developed emergency response plan, it is possible to minimize the potential consequences of an accident in a hazardous location. The key takeaway is that determining whether an area is a classified location requires a careful and thorough assessment based on the specific conditions and materials present. This assessment should be conducted by qualified personnel who are familiar with the requirements of the National Electrical Code and other applicable standards. If there is any doubt, it is always best to err on the side of caution and classify the area as hazardous. Remember, safety should always be the top priority when working with hazardous materials.